So, what is igneous petrology? The study of igneous petrology is a necessity to know geological sciences. It is concerned with the identification, classification, origin, evolution, and processes of formation and crystallization of igneous rocks. Most rocks available for study comes from the Earth's crust, but a few, such as eclogites, is derived from the mantle. Moreover, instruments used in igneous petrology, as well as the textures, compositions, and primary structures of the igneous rocks, will be discussed furthermore in this part. Instruments used in igneous petrology. First, petrographic polarizing microscope. It is the basic instrument of igneous petrology. Furthermore, the majority of instruments used today have to do with determining rock and mineral chemistry. These instruments are highly computerized and automatic and produce analysis rapidly, including the following: X-ray fluorescence spectrometer, equipment for neutron activation analysis, induction-coupled plasma spectrometer, electron microprobe, ion probe, and mass spectrometer. Moreover, complex high-pressure experimental laboratories also provide vital data. So what is igneous rock? Igneous rock is derived from the Latin word ignis, meaning fire. Formed when hot, molten rock crystallizes and solidifies. The melt originates deep within the earth, near active plate boundaries or hotspots, and then rises toward the surface. Igneous rocks form when magma, or molten rock, cools and crystallizes at volcanoes on the surface of the earth or while the melted rock is still inside the crust. All magma develops underground in the lower crust or upper mantle because of the intense heat there. Classification of igneous rocks. First, intrusive igneous rocks. Intrusive or plutonic, igneous rock forms when magma has trapped deep inside the earth. Great globs of molten rock rise toward the surface. Some of the magma may feed volcanoes on the Earth's surface, but most remains trapped below, where it cools very slowly over many thousands or millions of years until it solidifies. Slow cooling means the individual mineral grains have a very long time to grow, so they grow to a relatively large size. Intrusive rocks have a coarse grain texture. Second, extrusive igneous rocks. Extrusive or volcanic, igneous rock is produced when magma exits and cools above or very near the Earth's surface. These rocks has formed at erupting volcanoes and oozing fissures. The magma, called lava when molten rock erupts on the surface, cools and solidifies almost instantly when it has exposed to the relatively cold temperature of the atmosphere. Quick cooling means that mineral crystals do not have much time to grow, so these rocks has a very fine-grained or even glassy texture. Hot gas bubbles often trap in the quenched lava, forming a bubbly, vesicular texture. Formation of igneous rocks. Cooling. In this process, intrusive igneous rocks cool from magma slowly in the crust. They have large crystals. Extrusive igneous rocks cool from lava rapidly at the surface. Crystallization. A process wherein solid crystals has formed from another paste, typically a liquid solution or melt. Solidification. A process in which atoms has converted into an ordered solid state from a liquid disordered state. Composition of igneous rocks. Color is often an indicator of the composition of a rock or mineral and can effectively used to identify the composition of most igneous rocks. Light colors, including white, light gray, tan and pink, indicate a felsic composition. Felsic composition are rich in silica. Dark colors, such as black and dark brown, indicate a mafic or ultramafic composition. Mafic compositions are poor in silica, but rich in iron and magnesium. Intermediate compositions have an intermediate color, often gray, or consisting of equal parts of dark and light mineral. Beware that even though an igneous rock may have a felsic composition, the rock can contain dark-colored minerals. Mafic rock may contain light-colored minerals as well. As mentioned above, the composition of most igneous rocks is identified using this system, formerly known as the color index. However, there are exceptions. The two most notable are obsidian and dunite. Obsidian is volcanic glass that erupts as a lava flow. Most obsidian is felsic in composition, yet typically it will have a very dark color. Dunite has an ultramafic composition, yet is apple green to yellowish green in color. Dunite is composed almost entirely of the mineral olivine that usually contains both iron and magnesium. Textures of igneous rocks. The texture of an igneous rock does not refer to the roughness or smoothness of the surface. Textures are based primarily on crystal size. Pegmatitic texture is composed of very large crystals, larger than 2 to 3 cm. Phaneretic texture is composed of crystals that are large enough to see but smaller than pegmatitic texture, and the entire rock is composed of crystals. Aphanitic texture is a fine-grained texture but the crystals are too small to see. Porphyritic texture is composed of crystals of two different sizes. Typically, the large crystals are visible while the smaller crystals are not. Glassy texture is the most readily recognized. The rock is composed entirely of glass. Few, if any, crystals will be visible. Vesicular texture has formed when lava solidifies before gases are able to escape. The result is a bubbly appearance. Lastly, pyroclastic texture is composed of volcanic fragments. These fragments or clasts can be very fine, or coarse, or very coarse. Igneous rock identification chart. The color of an igneous rock has related to the colors of the minerals present. Rocks that are rich in silica usually contain considerable quartz and light-colored feldspar. Rocks rich in magnesium and iron tend to contain olivine, pyroxene, amphibole, and biotite. These minerals tend to be strongly dark-colored. Based on the amount of color versus white, a color index can be set up that relates to the composition. A rock that contains less than 30% colored minerals has considered light and called felsic from feldspar and silica. With 30 to 60% colored minerals, it is called mafic from magnesium and ferro, meaning iron, and with greater than 60% ultramafic. Primary structures of igneous rocks. Layered intrusion, usually placed at the graven structure that has crystallized at depth in large magma chambers. Dike. It is a discordant or cross-cutting tabular intrusion, usually igneous in origin. These are forming vertically or almost vertical, having pushed the country rock and generally harder than they have. Most dikes range under 3 meters in thickness but are often considerable length. Sills. Sheet is the other term for sills, flat intrusion of igneous rock that forms between pre-existing layers of rocks. Mostly, common sills are oriented horizontally. Basic compositions vary in thickness from a meter or less 10 meters. Lava flow. A stream of magma discharged on the ground surface from a volcanic vent or fissure. It could be from single flow or redundant. Example of lava flow are the following. Pillow lava. Contain pillow shape forming underwater, often have lineation or scrape marks on their sides that form during extrusion. Pahoehoe flow. It has comparatively smooth or ropey surface, forms when lava flows more slowly. AA flow. Its surface is consisted of free chunks of very angular pieces of lava, forms when lava flows rapidly, forming very rough surface. Pyroclastic flows. These are fluidized masses of rock fragments and gases that move rapidly in response to gravity. Additionally, the large size of the fragments within the welded rock that indicate the closeness from volcanic vent.